So what we're going to go over first is...
Anybody have any donations?
Yeah.
All right.
So first off, before we get into too much of how to do all these, and let's go back and recall what's the difference of what you're doing now compared to what you did before. So we started off with, let me rephrase that. There we go. We started off with linear equations, which basically when you graph them, it turned into a just straight line. So something like that, right? It's a regular straight line. Now, a lot of what we're doing today kind of comes from this, but is not going to be similar as far as the graphs go. So, exponential. Yeah. You'll see that the graphs grow this way. Okay? And it's good to understand why that is. Okay? First off, think about one of these word problems we're going to look at. It's kind of like, I don't know, how to get like clicks on YouTube videos. Some people, you've probably seen on YouTube, they have like, you know, millions so views or something like that, and they actually make a living off it. They get all these clicks, which... Okay. So you get all these clicks, which sometimes have ads on the videos, which gives that person that posted that video money. They get paid for that, so they can actually make a living by having lots of viewed videos that they make or video and put up there. So which one of these kind of illustrates how the number of clicks on a video goes? Exponential. So if it was linear, what would it look like? So think of the x-axis as the number of days it's been up. Okay. So the first day, second day, third day, fourth day, right? If it only was linear, that means it would go up by the same amount each day. So it's like each day you get exactly 4 clicks or exactly 5 clicks, and that's it. That's what causes it to be a straight line. But in reality, when you look at this, 1, 2, 3 days, right? It goes out to a few people, but then those few people can share it with more people, right? And then those, like, let's say 7 people share it with 5 other people that they know, 5 each. So you'll find that it actually starts increasing really fast at some point. It starts off like this, which is basically straight, but there's some break-even point where all of a sudden it jumps up really fast. And that's what those people are trying to do. They're trying to get past this magic point where all of a sudden it's popular enough that it grows, like it goes from like a 100 to 10,000 like really fast, and 10,000 to 50,000 really fast, and even faster. It starts growing exponentially as opposed to just it goes up exactly by 5 or 6 each day. Right. So that's the difference between these. And you want to be able later on, since we're going to be doing lots of different types of graphs, figure out, well, what type of graph is this? If I give you a type of scenario like YouTube clicks or something like that, you could say, well, that's exponential because of this. Or say like the speed of a car driving, you could say, well, that's probably linear, because of this reason. So we have many of these different types of graphs, and it's good to know each one, but know why they're different and know when to use them. Okay. So today, again, focusing mostly on exponential from real life situations. Now that we know the basics, we can kind of look at how to figure out these equations for them. So you come across the problem. How do you actually break it down to, well, here's the equation that will give you answers without having to do a whole lot of work. So go ahead and read this. Now, this is an actual thing that happened several years ago. There's this social experiment where someone paid for the next person's drink. Said, I'll buy mine, but I'm going to buy whatever they buy next, I'll pay for it. They just give them extra money and then they leave. And they're trying to see how long would that go for. Like somebody comes in and orders whatever they want, and they get their drink, and the cashier says, the last person already paid for it. And how many times or how long would it go would that person then say, okay, well, here's the money anyway that I was going to pay. Let me buy the next person's drink and see how long that goes. Now, how long do you think that went for? Like if you walked in Starbucks, someone said, I bought, someone already paid for your drink, and then you say, well, I was going to buy something anyway, so let me get the next person's drink. How many days do you think that would go for? Well, for about 46 days. Yeah. Yeah. So, and it was shocking because, especially now, we live in some sort of world of pessimism and maybe not trusting as much. But turns out that people are actually nice. And believe it or not, you might think, because a lot of people say, well, just maybe 1 or 2 days, and that was it. But it went on for over a month until someone's finally said that, no, I'm just going to take, and that's it. Right? So we knew it was going to end at some point, but that's pretty remarkable. Now the question is, if you had a situation like that, how could you figure out how many people, okay, or predict, like, what if it went on for 50 days or 70 days? How can you figure out or predict how many people that would have been? Okay, so that's what we're kind of doing here. We're starting off with maybe just a few days and figuring out, well, what would happen down the road. So, yeah, there's mathematics behind that, of course, and we want to see if we can figure that out and be able to predict what's going to happen. The number one way math is used more likely is prediction. You find out, well, what's already happened, find out some equation that figures out, well, if I plug numbers into this equation, it's said what's already happened, and then you put in numbers that are like in the future. Like you find out my equation works for the first 12 months, well, you put in, 2 years and see what comes out of it, and that's a prediction, what's going to happen. Now, of course, they do this with all sorts of things, like when they sent objects into space before they actually been there, they had to know, well, what was going to happen? How do you kind of send a person into space and make it come back when you've never been there? And they use all these equations, and then they can kind of predict it, right? So that's what it's all about. That's what the stock market's all about. If you can do that very well, you make a lot of money, millions and millions of dollars. Right? Finding out the equation, using it to predict what's going to happen, and then you can buy and sell your stocks and bonds and things like that to make money from it. So we're starting at the most basic level, though. So very simple example first. So if person 1 buys a drink, 2 drinks, next 2 people, right? And person 2 buys 2 drinks. Right. So to start off with, there's only 1 person. Total, we're talking about people, by the way, here. First. Okay. And on the second day, Madison bought for 2 people, and then those 2 people bought for 2 people. So far we have a total of 4. And continue this. That person buys for 2 people. And you see, it's not going up by the same amount. So it's not linear. That's a big thing here. It went up by 1, then it went up by 2, and now we have 8. So it's going up by 4. So it's not increasing by the same amount, so we know if we graphed it, it wouldn't be a straight line. And then those go up, each of those, by 2. Now, of course, it's any original problem that's ever been stated with some difficulty is probably started off with a picture or a graph of some sorts. And then from that graph, I'm just going to draw those in here. And from that graph, you find patterns, you make predictions, and you try to get the equation. And if we count all these up, let's see here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total. Okay. Now, and then you look for a pattern. Okay. So it's increasing by how's it increasing? It's doubling. So what's a possible equation we can use here? The total number of people, that's what is going to be equal to. Okay. And a good way of looking at this is that this is just 1. This is 1 times 2. That's how we get 2. How do we get 4 from this number here? You multiply that by 2. So we have 1 times 2, and then we multiply it by 2 again. And then to get the 8, we took this number, which 1 times 2 times 2, which is 4. We took that number, and then we multiplied that by 2. And then an equation or a pattern emerges that, okay, we're just getting 1 more 2 each time we go up to the next day. And you guys know how to write this mathematically, right? That'd be like 2 to the 4. This would be 2 to the 3. So you just keep on searching until you find some sort of pattern. This is 2 to the 1. So on day 1, it's 2 to the 1. On day 2, it's 2 to the 2. On day 3, it's 2 to the 3. Day 4, it's 2 to the 4. So what about any random day? Like so day n, they call it. It'd be 2 to the n power, right? So the number of random acts would be 2 to the n. Now, there's also this other number out front here, the 1. That's where we started. We could put that in the front of the equation. It wouldn't change anything, or we could just multiply it at the end. It wouldn't change the answer because multiplying by 1 doesn't change the answer. But that's also there as well. So we can't just look at all this pattern here and say, oh, look at all those 2's and they're growing. And then this other number by itself here, just say, well, it doesn't matter, just forget about it. It's there also, so we kind of have to do something about it in our equation. Okay? So there is a way of figuring out these exponential graphs. So first you have to figure out it's exponential, and then write it out, and you can see the pattern come out. So there we go, we have the pattern. We could also say, oh, well, that should be down here. We could say, if it asks you to describe what's happening, oh, the number of people is doubling each day, or increasing twofold. It's a way of saying doubling as well. And then finally in part C, go ahead and use the equation to predict. And you get 64, and it's a word problem, so we should have units. 64 what? Find the total number of Starbucks coffees. So you can say cups of coffee or it's coffee. Yeah, coffees. Right, something like that. Usually with anything that's word problem, you want to write it out. Okay. All right, that's the long version explaining a lot as we go along. Okay. So we'll speed it up, kind of using the same idea here. Okay, so read this one if you haven't already. Identify what is different compared to number 1. What's different about this compared to number 1? It's the 4 or 3. How many are we starting with? 3. Yeah, we're starting with 3. And the last one we just started with 1 matters. So you're going to see, well, how does changing from 1 person to 3 people affect? Yeah. Go ahead and draw. You want to make predictions. Well, this person. This person. Count them up. How many? And you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. One more. 12. And do one more. And at some point, this becomes too cumbersome and tedious. And that's why, one of those reasons why we want to have the math instead of having to make these charts forever and ever and ever. But as you can already probably predict,
40 times 2. That's times 2. But you don't.
okay? And without actually drawing it out, what do you think the next one is? Now, how did I figure out the equation before? So look for a pattern. If you need to. So going back here, write it out the way I showed you. This works very, very well. Instead of just having, 1, 2, 4, 8, 16. What's the formula? I don't know. It gets kind of lost. But when you wrote it out this way, 4 is really 2 times 2. 8 was really 2 times 2 times 2. And then you can see a pattern develop between the x bars. So let's do the same thing here. But we're starting off with 3. Right? So start off with 3. And how did we get 6? Well, that was just doubling 3. Okay. We started off with 3, and we ended up with 6. And how did we get 12 from 6? That doubled that. So you can see a lot of these problems that are different from the beginning start looking very similar. So the only thing different that you'll notice is that we're starting off with 3 here. But the other part, like the fact that we double it once and then double it twice, that has not changed. Same thing. And that's, as always, the trick with math when you have a bunch of different problems. Find out how they're the same. Don't look at each one and say, well, now how do I do this? You have to really just look for, well, how is this the same as what I just did? And just tweak it a little bit. So what would be the equation here? Based upon what we did before. Any ideas? Yep. Yep, P of n, that's in the directions. So 2 to the n. That's 3. Now, technically, here's how you see it written, like this. So usually not the 3. The 3 would usually be first, and then in parentheses have the exponent. But this is how you actually calculate it, right here. You do the exponent, and then you multiply it by 3. Same way you do it here, you just have to use one of our equations. Not just do 3 because it's first, but do the exponent still first, and then multiply by 3. Then we can go ahead and figure it out here. It says find the total for 6 days. So P of 6. And that comes out to the 6 is equal to 64. Okay. And 3 times 6 is 192. 192, say, meals. Yeah. Okay. Little sidebar. Now, how would you calculate 2 to the 6 if you had to do it mentally? Obviously, it means this. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and then times 2 is 64. That is, by definition, how you figure out an exponent, right? A little bit easier way is to do this. What are these two equal to? 2 times 2 times 2. 8. And then just do 8 times 8. 64. So same answer, but you can see I only had to do really 2 calculations. Find out what 2 times 2 times 2 is. It's 8. And then it's the same thing here. It's identical, so it's 8 times 8. That way you're not doing 2 times 2, 4 times 2, 8 times 2, 16 times 2, and so on. So it'll save yourself a little mental strength there and get a little faster with your exponents. That's, of course, faster than the calculator if you know how to do that. Alright, move on to the next. Now, you guys seen sports tournaments and things like that? So, very similar, very realistic. But how can we describe this mathematically? Yep. All right. Okay. So let's look at this. So the idea with the tournament, this is an NHL tournament, which is hockey, National Hockey League. That's what it stands for. Okay. And it says after each round, half of the teams are eliminated. So that half comes from, for every game played, there's only one winner. So we're assuming there's no ties at all, and that after each round, there's only one team winning each game. So how is this different from what we just went over in the first two? Yeah. So we're starting with 32, and we're going fewer, right? Yeah. So it makes sense that we should go down. Otherwise, anytime you had a soccer tournament or anything else, can you imagine after the first round there's more teams than when you started? That would not be good because no one can ever win the whole thing, win the tournament. So the idea is you keep on having two teams play over and over and over until finally there's only one team left as the champion. All right. So after one round, how many teams left? 16. All right. We just have to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? So it makes sense. Half the teams are still there because only half of them can win. But then those teams start playing each other. So from these two, there's only one winner. There we go. And how many? Proven. Okay, 8. Now let's use the same thing that we did before. Let's review. We always had, we always had, whatever we started at, it seemed to be stuck there throughout the whole problem in the front. So this is where the math comes in. And some of the math is common sense. And the common sense here is, well, if it's worked so far, why would we try to figure it out again as if we don't know? We already know it's working if we do it a certain way, so just kind of assume it's going to keep working, but test it, of course, just in case it doesn't. So if we've seen the same number we started with always in the front, let's do the same thing here. So we know we're going to start off with 32 teams. How are we going to get down to 16 teams? Or multiply by a half. Yeah, half of 32 is 16. And then we take this, which is 16, and how do we get 8? Okay. Take half of that. Okay. So it's very similar. We're starting off with 32, and we're decreasing, right, by half. Now, generally, you would write it like this. This is kind of you have a choice of dividing by or multiplying by half, dividing by 2, multiplying by half. Generally, multiplying by a half is more accepted because once you get away from a half, and what if it's 2/3 or 9/10 and things like that, you don't want to be messing with denominators at that point. So that's why we use multiplying by half. Okay. And from there, what would the equation be? Okay, again, don't try to figure it out. Look at the evidence you already have. Right? So we had 3, 3, 3, 3, and then we ended up having a 3 in the front of the equation. And this time we have 32 in the front, repeating. That's what we started with, so it makes sense. Well, 32 should be in the beginning. Okay. So we're not trying to figure it out and do the same thing all over again. It's using the pattern. All over these, we're multiplying by 2. 2 times 2, 2 times 2 times 2, and so on. So we end up with 2 to the end. And here we have, instead of 2, it's multiplying by half. Multiplying by half times a half. So it makes sense that instead of 2, we have a half. And that's the biggest skill you can develop mathematically here, is just figuring out a pattern and then trying it anyway on the next problem and seeing if it works. Not that it always does, but not starting over every single time will save you a lot of time. Right? And if you ever want to check just to make sure, you can always just plug in 1, 2. If we plug in technically 0 here, we should get 32. After 1 round, we should get 16. After 2 rounds, we should get 8. So if you plug in 1, 1/2 to the 1 equals 1/2. A half of 32 is 16. And it'll check out every time. So how many teams remaining after 5 rounds? So let's plug in 5. Go ahead and calculate, see what you get there. I don't know. I don't know. Question is, what if you put the exponent in the inside of the parentheses, like this? If I put the 5 up here? Technically, that means only the ones being raised to the 5th power. So the parentheses make it be the whole fraction. Good question. We don't want that. Because 1 to the 5th would just be 1. Yeah. So do the exponent first. What does that equal? 1 over 32, okay. So we know this is multiplied by 32, which equals what? 1. So, so that makes sense that at some point, you have to have a winner. So in this particular tournament, it takes 5 rounds of single elimination to get a winner. Single elimination just means if you lose 1 game, you're out of the tournament. And there are other that are, if you lose 2 or 3 sometimes. All right. So somewhat similar, but you'll find that something's missing here. Read this. Reading this, identify what's different about it.
It's exponential.
It's exponential. But what information is different as far as what's given to you? How much is it increasing or decreasing by? Is it a half? 2? Does it say?
No.
Yeah, it doesn't say. So that's important here. No, we give you very precise examples for very precise reasons, and you want to look at this and say, well, why is this on here? It can't be just like the last one, otherwise why would we be doing it? We want to think about, well, how is this different? So when I come across a problem like this, I know, well, this is kind of like that one that's different. So if you go back and you reread all these, you'll see that all of them tell you exactly, well, this is decreasing by a half, or this is increasing by 2. It's doubling. Yeah. But this one does not say how much is going up or down by. So it just bounces. Okay. It's 8 feet. Bounces 8 feet, which is that means that this is being dropped at really high, like off the balcony here. Or to bounce 8 feet, like one bounce and it goes, way over your head. And then it bounces another time and it says it goes to 6 feet. And then it goes down to 4.5 feet. Or 9 over 2. So how can you predict how high it will go? And when it will eventually stop bouncing. So we did it before. You would start off with just whatever we start off with, 32 teams or 3 people or whatever. Here we're starting off with 8 feet. And then we had it for all of these, but 8 times what will give us 6? Right? So if we follow the pattern over here, we got 16 because of what we started off with times a half. So we need to figure out, well, what do we multiply to get that number? I heard 3/4. Does that work? 8 times 3/4 is 6. Yeah. So the question is, how did you come up with this? If it's not given to you, that's what's different about this. How do you come up with that? another good strategy is look at an easier problem. So go back. How can we get a half? How can we figure out if we, let's say they didn't give us that, how can we figure that out with these two numbers? How can we get a half? Using 16 and 8, how can we get 1/2? Yeah, 8 over 16 equals a half. And that would have given us the number even if they didn't give it to us. So we know we can take one of the rounds here and put it over the previous one. Notice how this one's on top. Put it over the previous one, and that will give us how much it's increasing or decreasing by. So we can use that here. We can take 6, okay, and then put it over the previous one, which is 8, and then it reduces to 3/4. And that works with all the other ones as well. They're just given to you ahead of time. And then of course, the rest of it is all the same. So this one's going to be 3/4 times 3/4, and so on. And you can come up with your equation. And for the pattern, you can say it's decreasing by 3/4. Some others might say, well, I like decimals, say 0.75. Some others that maybe if you're not talking to a math person, percents might make more sense. So it's decreasing by 25% each bound to get 25% less. And there's different ways of saying the same thing there. So we can say, well, our equation here then, what's going to start with?
8.
8, right? Follow a pattern. And then 3/4 and power. You can figure out the 4th bounds. Really just the 1, 2, 3. The next one right here. 3/4 times 3/4 times 3/4. This one would be more practical to use a calculator of some sort to figure it out. We start getting into decimals, which is way more realistic. Most of the time there are some fractions of decimals involved. Rarely does it come out to be perfect. So 3 to the 4th power is 9 times 9. 4 to the 4th power is 16 times 16, which is, wait, calculate that. And 4 to the 4th?
108.
Right off to the side, 16 times 16. Okay.
112. 112.
Ready?
You gotta add zeros.
That's 500 off.
Ready? And to multiply those two, probably a calculator. You have one, do 81 divided by 256. Right, get some sort of decimal. Do it over here. Or you can do 8 times 81 and then divide it by. And not to lose focus right now.
Oh, how did you get that? I don't know.
So it comes out to about 2.53.
I didn't know.
All right. There we go.